Hello. Now we're going to talk about how and if reactions occur when we mix two aqueous solutions together. So let's imagine we have two aqueous solutions, They look like just solutions. You can't see anything in there. They may be blue, they may be purple, but they're transparent. They look like one thing. They're homogeneous. They're solutions. We mix them, and when we mix them, does a reaction occur? If a reaction occurs, we're going to see a precipitate, which is a solid, form at the bottom. This would be a sign that a reaction occurred because the precipitate is something new. Or no reaction occurs, in which case it just looks exactly the same. Or it doesn't, or more clearly, no solid formed. If no solid forms, then no reaction, you can't even read that, no reaction occurred. When the reaction occurred, we call that a precipitate reaction because this is a precipitate. So we're going to learn about that today. So here is an example. We're mixing a solution with another clear solution, and when they're mixed, you see a yellow solid form. That eventually settles to the bottom. So what was this reaction? One of these solutions was potassium iodide. These are the reactants. I'm circling them right now. Potassium iodide. And the potassium iodide was dissolved in the water. So like you saw in the last video, the way this Ki is being shown in a diagram is as ions that are separated because they're dissolved. They did not draw the water molecules around each one because that would be too complicated for the picture. But they're not being shown as K, as a molecule that's together because they're dissolved and the water has separated them. Similarly, the other solution that we're mixing in is lead nitrate. I'm circling the symbol for that now. That is being shown as being dissolved. So the lead is separate from the nitrate molecules. They're being mixed, and when they mixed, let's look at what happens. It says it down here. The lead, which is the yellow, and the iodide, which is the purple, combine to form a solid. We call that solid a precipitate. So in the drawing, I'm going to circle it. They're showing the solid as a rigid structure because these are stronger bonds between when a solid forms. They're stronger intermolecular forces. They're actually bonds. They're ionic bonds that are holding these together. So ionic bonds are being formed. Those are stronger than intermolecular forces. Now if you look carefully, and we'll come back to this later, not every single lead and iodide formed the solid structure, but almost all of them did. We'll come back to that when we talk about weak electrolytes. Okay? So at the end, we have our solid, which is the yellow stuff. That's called a precipitate. Precipitate, I have that written on your paper. The definition of a precipitate is a solid that forms, I'm making this up, a solid that forms as the result of a reaction of two solutions. That's what a precipitate is. The other thing you have in the clear part here are the ions that did not react. You have some of the nitrates and the potassiums. They did not react, so they're still floating around, and you can use your brain to imagine them surrounded by water molecules, each one of them. Oops. So, how do we know if a precipitate will form when we mix two solutions? We know because scientists before us have done many experiments and written down their results. There are certain guidelines. If you've seen Pirates of the Caribbean, these are guidelines, not hard and fast rules, for how precipitates form, how solutions react with each other. You're not going to have to memorize this table, but you will have to use it to determine if a precipitate will form or not. However, you will have to memorize that if a soluble compound that's formed will be anything that's made up that contains a group 1 metal or ammonium ion. So that you'll have to memorize for the AP exam. I'll double check that. They used to have you memorize all this and even more than this. They've changed the rules. But you will have to use this on the test. I'll give you this table. You will have to memorize this. But we're going to talk about how to use this. What this is telling you is that if a compound is created that contains nitrate, acetate, chloride, bromide, iodide, or sulfide, it will be soluble. Unless, exception, unless there's no exceptions to the nitrate. If it has a nitrate in it, it's soluble. No exceptions to acetate. There is an exception to chloride. If it is silver chloride, mercury chloride, or lead chloride, it will be insoluble. So the exceptions here, you're doing an exception to solubility, which means it would be insoluble. And so on. Let's look down here. What this part of the table is telling you, any compound containing sulfide, carbonate, phosphate, or hydroxide will be insoluble unless, there are exceptions, it's ammonium sulfide, that would look like this, NH4S, that's going to be soluble because the exceptions to insolubility will be soluble. Calcium sulfide, CaS, will be soluble. So the exceptions are the opposite of what the general rule is. We're going to work with this now. So I've put this question on your paper. I want you to classify these two ionic substances as either being soluble or insoluble or water. And we're going to use the table that we have on the previous page. In fact, I'm going to put it here. So I've put it here so we can use it. So we're looking now at sodium carbonate. Is sodium carbonate going to be soluble or insoluble? So let's look down here and see where we see either carbonate or sodium. We're looking for either carbonate or sodium in this here. Here I have carbonate. So I'm going to circle this. So this tells me that anything with carbonate is going to be insoluble. So maybe this is going to be insoluble. However, I have to check the exceptions before I write down insoluble. It says the exceptions are compounds with ammonium, no ammonium in here, and the alkali metal cations. Those are the group 1 metals. So then I say, well, is sodium a group 1 metal? Why, yes it is. Sodium is a group 1 metal. So that means sodium carbonate is an exception to this insoluble rule. So sodium carbonate will be soluble because it's an exception. Let's look at lead sulfate. So lead sulfate, I'm going to look for lead or sulfate down here. So where do I see lead or sulfate? Well, I see lead here. Okay, so lead's an exception. And I see sulfate here. So sulfate is going to be soluble, but I have to check the exceptions to see if lead is there, because if lead sulfate is an exception, then it will be insoluble, and I do see it here. So while some sulfate compounds are soluble, or most of them, when lead is mixed with sulfate to make a solid, that is insoluble. That is the exception. So this is going to be insoluble. Okay, now we're going to work on predicting the products when you have, and we learned this last year, as a double replacement reaction. We're going to learn two new words for this double replacement reaction. We're either going to call it a molecular reaction, and you'll see why in a minute, or this fancy word, which I've actually never heard before, metathesis reaction. You can stick with double replacement. So we have two solutions here, barium chloride and potassium sulfate. And we want to predict the identity of the precipitate, if a precipitate forms, when the aqueous solutions of these two are mixed. And then we're going to write the balanced chemical equation for the reaction. So the way we do this, the first step is to write the reactants. BaCl2. And it's important, I use this aqueous symbol over here because I'm showing that they're in solution, they're dissolved. The second step is to write the products as if you were doing a double replacement reaction. So you have to switch the ions in a double replacement reaction. So I rewrote it and I did it in color so you could see what happened. I moved the barium from the chloride to pair up with the sulfate and the potassium from the sulfate to pair up with the chloride. Notice I haven't written here if they are solid or aqueous yet, because we need to identify the precipitate. In order to have the precipitate, we're going to have to use to know what it is, we'll use our solubility rules. So these are blank. First, this reaction's not finished. I've rewritten it, but I haven't balanced my formulas and I haven't balanced the equation. So I have to make sure this potassium chloride is written correctly. Now the charge on chloride is -1. The charge on an ion of potassium is +1. So this is balanced. This is written correctly. Here I needed 2 potassiums because the sulfate is -2. Let's check out barium sulfate. We're going to check out barium sulfate. The barium has a charge of +2. You could double check that here if you forgot because it's paired with 2 chlorides. And sulfate is -2. So +2 -2, that's balanced. Now we have to check to see if the whole reaction is balanced. So we have 2 potassiums here, so we need a 2 here. That gives us 2 chlorides here. And we had 1 barium and 1 sulfate, so we're balanced. So we've rewritten the product, we've written the products, and we've put in a third, which is to balance the formulas in the equation. Our final step is going to be to predict the identity of the precipitate, and for that we're going to need our solubility rules. So I've added them at the top. So let's look. Is potassium chloride going to be a solid or an aqueous solution? So we're looking for potassium or chloride. Well, I find chloride here, and it tells me that chlorides will always be soluble unless they contain silver, mercury, or lead. And there's no silver, mercury, or lead here. This is potassium. So this is going to be a soluble compound, which means it's aqueous. Well, that's an A, and that's a Q. So that is not a precipitate. Let's check to see if this forms a precipitate. Barium sulfate. So I'm looking for barium or sulfate over here, and I find sulfate. And sulfate is also always soluble unless it contains strontium, barium, and this does contain barium. So this sulfate, this barium sulfate, is not going to be soluble because it contains an exception. It's going to be a solid. It's going to form a solid at the bottom. So that means this is our precipitate. The solid is the precipitate. So to answer A of part of this question, barium sulfate is our precipitate. I'm going to end this video here, and there's going to be one more short one talking about net ionic reactions.